Hello and welcome to Ramble with me. We're rambling about IEB May 2025 paper 1 today, question 7a. So we're going to be solving a series of equations. The first one involves a radical, 11 minus 2x plus the square root of 2x squared minus 29x plus 114 is equal to 0. So the general strategy where there's a radical involved is to isolate the square rooty term. So I'm going to move all the other terms across. So then that'll be negative 11 plus 2x, right? And then from there, we square both sides to get rid of the radical. So then we have 2x squared minus 29x plus 114 is equal to 121 minus 22x minus 22x is then minus 44x, and then 2x times 2x is 4x squared. Right, and then this is a quadratic equation, so I'm going to try make one of my sides equal to 0. So I'm going to move all my terms across to the left hand side, to the right hand side, whatever makes you happy. So we're going to minus 4x squared on both sides. We're going to plus 44x on both sides, and then minus 121 from both sides. So then we have minus 2x squared plus 15x minus 7 is equal to 0, which we can then put into the quadratic equation. I'm going to attempt to factorize it. It looks factorizable. How do I know that? Well, if I times negative 2 with negative 7, I get 14. And I can immediately think of factors of 14 that would add up to 15. 14 and 1 would add up to 15. So that tells me that it's factorizable. Not comfortable factorizing when there's a negative number in front of my quadratic term, so I'm just going to divide through by a negative. Definitely don't have to do that, but it is a thing you could do. Right. And so let's see if we can figure out the factors here. So this would have to be 2x and x, and then I want the 14 and the 1, so this would be minus 14 and minus 1. So this would give me my minus 14 term, and this would give me my minus 1 term. So that would be minus 7 and minus 1. So that's minus 14 and minus 1, well, minus 14x and minus 1x, which gives me that guy, and minus 1 times minus 7 gives me 7. So therefore 2x minus 1 is equal to 0, or x minus 7 is equal to 0. And so either 2x is equal to 1, which means x is equal to a half, or x is equal to 7. But then the very important thing, when you solve equations like this that involve a radical, we must test our answers, because, for example, I don't know if this is going to work in my favor, but root x is equal to 2x, for example. If I were to square both sides, I would end up with x is equal to 4x squared. So then that would be 4x squared minus x, and then factor out the x, so that would be 4x minus 1. So then either x is equal to 0, or x would be equal to a quarter. Whatever feeling this is going to work either way. It's going to work either way. That's a terrible example. Anyway, but we know that there are situations where because technically how do I explain this? So by definition, the square root is always a positive number, right? When you talk about the square root of 9, that is positive 3. It's not 3 or negative 3. If you wanted to talk about the negative square root of 9, you would have to put a negative there. So when we do something like this, where we square both sides, right, we are in a way kind of forgetting a restriction that this guy can only be the positive root of this expression, not the negative one as well. So yeah, because if you say x squared is equal to 9, technically x could be 3 or x could be negative 3, because these are both values that solve this equation. But if you had begun by saying that the square root of something is equal to 3, then it can only be the positive thing that I'm not explaining this well. I am messing this up so badly. Oh my goodness gracious me. Okay, let me think about this. Let me think about a good example that will illustrate what I am trying so desperately to say. So let's see if this one will work. Hey, wait. Okay, look, I don't know. It makes sense in my head. That basically this equal to this does not necessarily mean that everything that solved this can also solve this original equation. And at this point, it's just trust me, bro. So actually, the really responsible thing to do at this point would be to say that, okay, this is the equation we were solving before the squaring, and then when we squared it, we would need to add the restriction that this guy, we only care about the values where this guy is positive, because the square root is only positive numbers. So so even though whatever the value of this is, its positive and its negative version would be equal to this side because of the squaring. So for example, if we somehow knew that this expression has a value of 5, then if the value 5 works, the value negative 5 could also work, because if you square them, if you square both of them, you end up with 25. So even though technically that could work, because of the definition of a square root, we only care about the positive version of whatever this value is. Oh, this is a painful explanation. Like, it breaks my heart how painful this is, but it will just have to do. So if we were responsible at this point, when we brought in the squaring, we would have said, please bear in mind that negative 11 plus 2x has to be something that is greater than or equal to 0. Because if it's negative, then it can't be negative. It can't be negative, because then that would mean the square root is a negative number, and we know that by definition the square root of something is always positive. So our x has to be something that is so if we just quickly solve this inequality, so, and we know that that will switch it around, our x has to be something that is greater than 11 over 2. Okay, so let's see. From our solutions, we have an x that is equal to half, so that isn't greater than 11 over 2, so I can already tell you that that solution is not going to work. And then we have another possibility of x being 7, and 7 is greater than 11 over 2, which is 5.5. So that solution is going to work. So let's just go ahead and plonk both values in here and see what we get. So test x equal to a half. So the left hand side would be 11 minus 2 times a half plus 2 times a half squared minus 29 times a half plus 114, for which I am going to get the help of my calculator. So 11 minus 2 times, a half plus the square root of 2 times a half, I think that's outside, okay, yeah, minus 29 times a half plus 114. So that gives us an answer of 20. Right. And then on the right hand side, we have it's meant to be equal to 0. So the left hand side is not equal to the right hand side, which means that x isn't actually equal to a half. That's not, so actually x equal to half is not a solution to this equation, right? And then let's test the other one that we got. X is equal to 7. So in this case, we have the left hand side is equal to 11 minus 2 times 7 plus the square root of 2 times 7 squared minus 29 times 7 plus 114. Right, and once again, calculator to the rescue. I'm just going to get rid of the places where I wrote half previously. And now we are expecting that our answer is going to be 0. Let's see. And indeed, our answer is 0. Right. Left hand side equal to right hand side, meaning that the only solution to this equation is x is equal to 7. So yeah, if we come back here as a last attempt for me to explain the point I was trying to make, if we come here and we put in the x is equal to a half, what we're going to see is that this guy ends up being some negative number. Yeah. And so, yeah, okay, so let's just do it because talking is hard today. So if we put in, I'm just going to type 0.5 squared minus 29 times 0.5 plus 114, right? What we see here is that it gives us 100, right? And the square root of 100 is positive 10. That's very important. It's not 10 or negative 10. A square root can only be 0 or a positive number. So this is what this side of the equation would be if we put in a half. If we then come on this side and we say negative 11 plus 2 times 0.5, we get negative 10, right? So do you see, hopefully you see now what the error that has crept in by squaring both sides, right? By squaring both sides and not stating a restriction. Because yes, negative 10 squared is going to give you, So we said that if we put a half in here, we get the square root of 100, and if you square that, you do indeed get 100, right? And then on this side, you get negative 10, and if you square that, you also get 100. So that is all good and well, that is hunky-dory. But the problem is that we can't allow this expression to just be anything. This expression can only be something that is 0 or more, because this expression is equivalent to a square root, and a square root can only be 0 or more. So yeah, you could just stick with the good old thing of, you know, whenever you see a radical and you know that you need to take all your terms to one, all the other terms to one side, keep the radical alone, and then do the squaring, and then find your solutions, and then you test your solutions. That is a perfectly okay way to figure out which solutions are valid or not valid. But I think a more correct way is, at this point, when you introduce the squaring, you need to state a restriction on the solutions that are going to come out of this equation. Now, that the only solutions that are going to be valid are ones where this guy is positive, right? Because if we're saying that this guy is equal to this guy, then already that tells us that this guy has to be something that is 0 or more, and therefore we are only looking at solutions that meet this restriction. Whew, I'm sure I'm already on 30 minutes, and it's a very questionable 30 minutes spent. Let us move on to the next equation. We have 0 is equal to 5 to the 2x minus 9 times 5 to the x minus 10. So already what stands out for me is that there's a 5 to the x here and a 5 to the x in disguise. This is a 5 to the x to the power of 2. And this is a 9 times 5 to the x, and this is a minus 10. Where does this come from now? Right, and so therefore we can replace the 5 to the x with like a k, just so that we can see more clearly that this is a very beautiful quadratic equation. Again, you could plonk it into your quadratic formula, but if you're comfortable factorizing, save time, guys, save time. So now either k is equal to 10 or k is equal to negative 1. So therefore 5 to the x is equal to 10, or 5 to the x is equal to negative 1. Right, 10 is not a power of 5, right? The powers of 5 are 1, 5, 25, 125, and so it goes. So we're going to need to use logarithms to solve this, right? So x is equal to log base 5 of 10, which is going to be something that needs rounding off. I think in IEB we're rounding off to 1 decimal place. So let's do that. So that is going to be about 1,4. And then for this guy, we don't get any solutions. And that is because if you think about the graph of y is equal to 5 to the x, right, we can see that all the outputs of this function are positive, greater than 0. So there isn't an x that's going to give us an output that is below, yeah, the x-axis. So no solution here. So this is really the only solution that we get. And of course we can just double check it very roughly. So I will use the rounded value and we should get something close to 0. Oops. Right. We do not. Isn't it lovely? Isn't it wonderful? Yeah, because that is, I would have thought -5 is quite far off, man. Even for a rounded value in my books. So let's just double check. Let me just use the proper value. Shift store, I'll store it in A. Okay, so we want to say 5 to the power of 2, it may not be too radical, 2 times A minus 9 times 5 to the power of A minus 10. And we do indeed get 0. Okay, so clearly my rounded number is just too very rounded. Moving along. Okay, so that one was nice and quick. And then the last one, x to the power of 8 over 3 minus 9x to the power of 10 over 3 is equal to 0. What I immediately want to do here is to take out a common factor, right? So I'm just gonna show it to you. So x to the 10 over 3 is the same as x to the 8 over 3 times x to the 2 over 3, right? Using the, if they have the same base, you add the exponents, that rule. So then we have a common factor of x to the power of 8 over 3, and here we're left with 1 minus 9x to the 2 over 3. So then either x to the 8 over 3 is equal to 0, or 1 minus 9x to the 2 over 3 is equal to 0. I mean, there's nothing much going on here. 0 to the power of anything is 0. So that would be all that's happening there. But if you really wanted to, you could, you know, raise both sides to the power of 3 over 8, and yeah, 0 to the power of 3 over 8 would still just be 0. So x is equal to 0. Then over here we would need to, okay, maybe let me keep this guy on this side and then move this guy here, and then let's divide both sides by 9. So then x to the power of 2 over 3 is equal to 1 over 9. So let's just see what this means. So this is the cube root of x squared is equal to 1 over 9. Okay, so that makes it very clear to me what I need to do. I'm going to cube both sides. So that will be 1 over 9 to the 3, not in the mood to work out what that is equal to x squared. And then we just need to be careful here. If we go the route of taking the square root on both sides, we would have to consider both. the positive square root and the negative square root, right? So x would be equal to plus or minus 9 to the 3 is the same as 3 to the 6, right? 9 to the 3 is the same as 3 squared to the 3, which is the same as 3 to the 6. And the square root of that would be 1 over 3 to the 3. So that is x is equal to plus or minus 1 over 27. And let's just test that real quick. So I'm gonna store that. Oops, shift store inside B. So then we have alpha B to the power of 8 over 3 minus 9, and then that's 10, right? And that does give us 0. And then the other alternative is for this B to be negative. Oh, okay. So then it will be, oi, this is not what I wanted to do. So negative, the negative version, right? Oh, and that does not work. Ooh la la, ooh ooh ooh. Right, and I didn't mess that up somewhere somehow. So that is, oh, I'm so confused. Oh my heavens. Okay, so 1 over 27 works, and negative 1 over 27 also works, but somewhere, somehow, I don't know, maybe it's something, wait, okay, I need to resolve this for myself at this point. So maybe it's because I was meant to write it this way. No, there's something very weird happening here. Okay, I don't know, and this is not the platform for me to figure out why a calculator is behaving funny. Right, but it looks like it works. So let's have a look at what the memo has to say. I am not proud of how this video has gone. I don't want to lie, my word. So much of dribbling, so much of agony and pain. Let's at least hope I got things right. So x is equal to 7 is indeed correct. X is a half is not a solution, a valid solution to this equation. Oh my goodness, we are rounding off to 2 decimal places. Ay, ay, ay. But anyway, just squeeze it in. Right, indeed, x is equal to log base 5 of 10, which is 1,43. And then, yeah, we don't have any valid solution coming out of k being equal to -1. And then from there, we have, whoa, 2 solutions being x equal to 0, the one solution, and then the other one being x is plus or minus 1 over 27. Right, long walk to freedom, but we made it. I hope that was valuable. And of course, you know, I always welcome if people have like a clearer way of explaining something, like if you want to drop it in the comments, please do, and yeah, just to benefit the community that way. Right, okay, bye.